Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.54. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Electrical power calculation formula will also be utilized while solving this problem, that is the product of voltage across an element and current through that element. Now move towards the problem. Exercise problem number 2.54. Find power absorbed by dependent source in given below figure. This is the circuit diagram of given problem. We have to find power absorbed by this dependent current source inside this network. We know that in order to calculate power of an element inside an electrical network, we should have at least two parameters. One is voltage across that element and other one is current through that element. Right now we don't have both parameters related to this element. Current of this element is depending upon the voltage across this current source, that is labeled as VA, and the value of voltage across this element is also unknown. In this case, the voltage across this element will also be VA because of parallel connection. So first we will try to find out the value of voltage VA inside this network, so that we can calculate the current of this dependent source as well as voltage across this dependent source. Later on we will be able to calculate the power of this dependent source. Now for the calculation of voltage VA, we will apply Kirchoff's current law on this network. This network includes only two nodes. One is reference or ground node and other one node is our point of concerning node. All entering or leaving currents on this node will be taken with the reference of this ground node. But before applying Kirchoff's voltage law, first we have to identify the direction of currents inside these resistive branches. Right now, these resistive branches don't have any polarity of current nominated. So we have to assume the direction of current through these resistive branches. If we observe in this circuit, voltage across constant current source with their polarity is specified in this network, that is VA with their specified polarity. This same voltage will be appearing across all other elements because of parallel connection. So we can say that all other resistive elements will have positive terminal on this node and negative terminal on this node. And according to passive sign convention theory, through resistive branches we take current entering terminal positive and current leaving terminal negative. So in this case all currents through these resistive branches will be downward. Now Kirchoff's current law equation for this node will be 3 milliampere minus VA divided by 4K minus 2VA minus VA divided by 1K minus VA divided by 2K minus VA divided by 5K equal to 0. On this node only one current is entering, that is 3 milliampere, while rest of all other currents are leaving from this node. And these currents are calculated using Ohm's law. Voltage across these resistive elements, that is VA, dividing by the values of resistances. In this case VA divided by 4K, for this resistance VA divided by 1K, and for this resistance VA divided by 2K, and for this last resistance VA divided by 5K in a sequence. Current equation of this dependent source was given in the form of VA, so we have taken it as it is in order to make only one variable VA inside this equation. Now inside this equation only one variable is left, that is VA, and we are interested to calculate its value. So we will solve this equation to calculate the value of VA. For that purpose, we will multiply this equation with 20k in order to omit all denominator values. The equation will become this. Now this 20k will cancel out with 4k and the answer will be 5. This 20k will cancel out with 1k and the answer will be 20 only. This 20k will be cancel out with 2k, the answer will be 10 only. And this 20k will be cancel out with 5k and the answer will be 4 only. Now take the product of all remainder values and write equation again. The product of 3 milliampere and 20k will become 60 only, milli will cancel out with k. Product of 5 and VA will become 5 VA and product of 20k and 2 VA will become 40k VA. Product of 20 and VA will become 20 VA. Product of 10 and VA will become 10 VA. And at the last, product of 4 and VA will become 4 VA. Now add all these values that include variable VA together. The equation will become 60 minus 40.039 kVA. Here K is representing kilo. Place this minus 40.039 kVA on the other hand side of equal to make it positive. The equation will become 60 is equal to 40.039 kVA. Divide on both sides with 40.039 k to calculate the value of VA. That will become 1.49 millivolt. We have calculated the value of voltage VA. This voltage 1.49 millivolt will be appearing across all other elements inside this network. So in other words, we have calculated voltage across this dependent source, that is 1.49 millivolt. Now the current through this dependent source is depending upon the value of voltage VA, so we can calculate the value of current through this dependent source as well. That is the twice of value of voltage VA. So the current through this dependent source will become 2.98 milliampere. Now we have calculated voltage across this element and current through this element, so we can calculate the power of this dependent source. Power of this dependent source will be the product of current through it, that is 2.98 milliampere, and this current is taken with positive sign because current is entering from positive terminal of voltage across this element and leaving from negative terminal of this element. And voltage across this element is 1.49 millivolt. So the product of both values will become 4.4 microwatt. So this dependent source is absorbing the power of 4.4 microwatt inside this network. This was exercise problem number 2.54. Thank you. See you again in next video.